Exam 3 review for college physics students. The topics for this review are torque, rotational motion, statics, which is static equilibrium, and fluids. So those are the 4 topics. The first question has to do with torque. So let's consider that there are forces, 3 forces as shown in the diagram, acting at different points, B and C. So there is a force acting here. So this is a rod that can turn about a point A, and this force is acting at B, which is about half the distance. But there are 2 forces acting at C, and these 2 forces are acting at different angles. So one is acting perpendicular, the other is acting at some other angle. So the question now is, which one of these forces creates the biggest torque? And for that, we need to know that torque is the product of the distance r, the force F, and the sine of the angle theta. So when we talk about angle theta, this is the angle theta. So for forces 1 and 3, the angle is 90 degrees. You can see that the angle here is 90. The angle here is also 90 degrees. So which one creates the biggest torque? Of course, 1 is only halfway, so the distance r is smaller. So that cannot create a big torque. So that leaves us with 2 and 3. And sine of the angle 90 is maximum, which means that force that creates an angle of 90 will produce maximum torque. So the obvious answer here is force number 3. Again, because the distance is maximum and the angle is 90. The next question, in this question, a flywheel is turning at 600 rotations per minute. What is the angular speed? So whatever is given as rotations per minute, we cannot work with it. We have to find how many rotations it makes in 1 second. Since there are 60 seconds in 1 minute, that means we got to divide the 600 by 60 to get the rotations per second. And then we know that each rotation is 360 degrees or 2 pi radians. Now here we work with radians. So each rotation is 2 pi radians. And so you just multiply the number of rotations per second with 2 pi to give you the answer. All right, so 600 rotations per minute is 600 by 60, 10 rotations per second. And then angular speed omega is theta by t. The angle is 2 pi times 10 because there are 10 rotations per second, and in each rotation the angle is 2 pi, and that is made in 1 second. So the obvious answer here is 62.84 radians per second. What added to this question, if the radius of this flywheel is given as 20 centimeters, what is the linear speed? Now to know that, we need to know the relation between angular speed and linear speed, which is omega is v by r. So omega is the angular speed, this is the linear speed. We already have the angular speed, the radius is given, so it's a simple thing to find the linear speed. Just rearrange, multiply, you get the linear speed as 1256.8 meter per second. Next one, a wheel accelerates from rest to 40 radians per second at a uniform rate of 5.0 radian per second squared. Through what angle did the wheel turn while it was accelerating? So we need to read the question carefully and understand what the given terms are. The wheel accelerates from rest, that means the initial angular speed is 0. The final angular speed is 40 radians per second, and what's given here, it's angular. And the formula that connects these quantities is omega f squared minus omega I squared is 2 alpha theta. Rearrange that equation to make theta the subject, and we would get this, and substitute the values and calculate the value of theta. We're going to get the value of theta in radians. In this case, the answer is 160 radians. So that's the B part. So how many times, how many revolutions did it make while it was accelerating to make that angle? Now, as before, we know that the angle in one rotation is 2 pi radians. So the total angle theta is given by 2 pi times the total number of rotations. So we can use this formula. Total angle is equal to 2 pi times total number of rotations, because in one rotation the angle made is 2 pi. So when we rearrange that and make n the subject, we get 160 by 2 pi, which gives 25.46 revolutions. In this question, the next one, there is a meter stick which balances at the 51.0 centimeter mark. But if a mass of 25 grams is kept at the 80 centimeter mark, now the stick balances at the 62.0 centimeter mark, and you have to find the mass of the meter stick. So in this question, the first statement says the meter stick balances at the 51.0 centimeter mark, which means the center of gravity of the meter stick is 51.0 centimeter. Or, in other words, that is the point through which the mass of the meter stick acts. And then we have a 25 gram placed at the 80 centimeter mark, and the balance is at the 62.0 centimeter mark. So when you make the diagram, this is what we get. So here is the you have the center of gravity of the meter stick through which the mass of the meter stick m acts. The pivot or the balancing point is at 62, and the 25 grams is at 80 centimeter. So it's very clear that the 25 gram creates the clockwise torque, the mass of the meter stick creates the counterclockwise torque. And for static equilibrium, the clockwise torque must be equal to the counterclockwise torque. That means 25 multiplied by this distance should be equal to m multiplied by that distance. So 25 times 80 minus 62 should be equal to m times 62 minus 51. So 80 minus 62 is 18, 62 minus 51 is 11, and then when you do that calculation, you get the mass of the meter stick to be 40.9 gram. To the next question, which is to do with Young's modulus, elasticity. So here is a steel wire which has one end fixed rigidly, and at the other end you have a load of 20 kilograms. And so the steel wire stretches by 1.5 millimeter. The diameter of the wire is 1 millimeter, and we got to find the original length. The Young's modulus of steel is given as 210 GPa, which is gigapascals. We know that 1 gigapascal is 10 to the power 9 Pascal. So 210 multiplied by 10 to the power 9 is the Young's modulus. So let's list the given quantities. The force due to 20 kilograms is going to be 20 times 9.8. Because the 20 is the mass, and we need the force due to the 20 kilograms, which is 20 times 9.8, which is 196 newtons, and the area of cross section, because the cross section is circular, the area of a circle is pi r squared. So pi times the radius, what's given is the diameter, which is 1 millimeter, so half of that would be 0.5 millimeter, but we need it in meters, so it's 0.5 divided by 1000, or 0.5 times 10 to the negative 3. So either way, you put pi r squared, you get the area in meter square. That was supposed to be a square there, okay? This is supposed to be here, square. And then the change in length is given, the extension. Again, that's in millimeters, so you got to change that into meter. And then here is the formula for Young's modulus. And we are asked to find the original length, which is given here. So find L, make L the subject, and then you get this formula. On rearranging, substitute the values. The area was 0.785 times 10 to the negative 6. Extension is here. The force was 196. And we calculate that the original length of that steel wire was 1.26 meter. Problem: an object weighs 10 newtons in air and 8 newtons when it is immersed in water, of density 1000 kilogram per meter cube. What is the density of the object? So we do know that whenever an object is immersed in a liquid, the liquid is going to push up, and that's called the buoyant force. And in this case, the buoyant force is 2 newtons, because in air it was 10 newtons and in water it is 8. So the difference is always the buoyant force. And then we know the formula for buoyant force, which when we use, we can find the density of the object. So here we go. The apparent loss of weight, the word apparent means actually it's not losing weight, but it appears to have lost weight, is 2 newtons, which is the buoyant force. And the formula for buoyant force is the product of the volume of the fluid displaced times the density of the fluid times g. The fluid in this case is water. So we know that buoyant force is 2 newtons, and we do not know the volume of the fluid displaced. Incidentally, this volume would be exactly the same as the volume of the solid. Right? So the volume of the solid would be the same as the volume of fluid displaced. And the density of water is given as 1000, G is 9.8. When we do that, we will be able to calculate the volume of the fluid as 2.04 times 10 to the negative 3 meter cube. But that again is the volume of the solid. So now we know the volume of the solid, and to find the density of the solid, all we need is the mass of the solid. Do we know the mass of the solid? No, we don't. We know the weight of the solid, but we know that the weight is always mass times acceleration due to gravity. So knowing the weight of the solid, we can find its mass, just dividing the 10 newtons by 9.8. Once we know the mass, and we know this volume, just divide them to get the density of the solid. It's 500.2 kilogram per meter cube. Well, in real life, if the density is less than that of water, it will not sink, it will float, but I just threw in the numbers, so the working of the problem is correct. And we get, in this case, the density of the solid is 500.2 kilogram per meter cube. The problem, so I'm just going to explain what angular momentum is. Angular momentum is the product of rotational inertia and angular velocity. Rotational inertia has different formulas for different shapes. If it's a disk, excuse me, if it's a disk, rotational inertia is mr squared by 2. Now, where m is the mass and r is the radius. So I'm just assuming that the mass is 2 kilograms and the radius is 0.2 meters, and I'm calculating the rotational inertia, which happens to be 0.04 kilogram meter squared. So once you get the rotational inertia, and if you're given the angular velocity, we can find the angular momentum. So assume that the angular velocity is given as 3.0 radians per second. The angular momentum is now the product of these two quantities, which happens to be 0.12 kilogram meter squared radian per second. That's a big unit for angular momentum. And then could we find the rotational kinetic energy of this object? Yes, rotational kinetic energy is given by 1/2 I omega squared. 1/2 I omega squared. We know the rotational inertia, we know the angular velocity, so when we do the math, we will get the rotational kinetic energy as 0.18 joules. And I wanted to add a third piece, which is the conservation of angular momentum. And according to the conservation of angular momentum does not change. But there is a condition. The condition is that there must be no external torque acting on the system. So somebody is standing on a rotating platform with hands spread out, feet spread out. And if they suddenly pull their hands close to their body and pull their feet close to the body, their rotational inertia decreases because the particles are now closer to the axis. And when the rotational inertia decreases, the speed of rotation will increase. All right, because when I2 becomes less than I1, omega 2 has to be greater than omega 1 for the product to be equal. But remember, the condition is that there must be no torque acting on the system. That now brings us to the last question in this review. What is the pressure at a depth of 20 meters in fresh water? So there are two types of pressure. It could be the gauge pressure or the absolute pressure. In this case, I'm going to calculate the gauge pressure. The formula for gauge pressure is H rho G. Just multiply the depth or the height with the density and the acceleration due to gravity. So in this case, the depth is 20 meters, the density is 1000, and G is 9.8, so that gives us 196,000 pascals as the gauge pressure. Pretty simple. And now let's imagine that you have a circular disc at that depth, and if you're given the radius of that disc, can you find the force that acts on it? All right, so let's see. So what is the force acting, or what force acts on a circular plate or circular disc of 20 centimeter diameter, which is kept at that depth? So now we have to use the formula. Pressure is force by area. Once again, we are only using the gauge pressure. So the pressure is force by area. We know the pressure. And we can find the area of that circular plate. The area of a circle is pi r squared. So what's given us the diameter. Take half of the diameter, gives you the radius as 10 centimeter. And then that has to be in meters. So that will be 0.1 meter. That's 10 divided by 100. So when you do that, the pressure's already calculated. Oh, did I miss a zero there? I think I did. It's 196,000, but there is 1 zero less here. So I will correct that. And then times pi r squared is going to give you 61,575 newtons. 61,575 newtons. Check that out. I may have put 196,000 in the calculator, so you really need to check that out. So I think I may have just forgotten to write that extra zero there. So that's how we work out the problems. Good luck on exam 3. I hope you study all this, understand each question. Thank you.